There's a place in the sky that should not exist. It is older than every star, older than every galaxy, older than the earth beneath your feet. And hidden inside the oldest light in the universe, light that has traveled for nearly 14 billion years to reach us, there is a scar. A region of space colder than it has any right to be, larger than anyone can explain. And after more than 20 years, after 2 spacecraft, after the most powerful instruments humanity has ever built, no one on Earth can tell you why it's there. Some say it's a fluke. Some say it's a flaw in everything we believe about the cosmos. And some believe it is a wound, a bruise left behind when our universe collided with another one. By the end of this video, you'll understand why that last idea terrifies and thrills cosmologists in equal measure. But to get there, we have to go back to the very beginning, to the moment light itself was born. More than 13 billion years ago, the universe erupted into existence in a burst of energy beyond anything human experience can compare to. And then, for hundreds of thousands of years, the cosmos simply glowed. Not darkness, not emptiness, a suffocating fog of charged particles, so dense that light could not move. Every photon born in that inferno was instantly swallowed, scattered, trapped. The entire universe was a prison of its own brilliance, opaque from edge to edge, screaming with light that had nowhere to go. For 380,000 years, nothing escaped. And then, as the universe expanded and cooled, a quiet miracle unfolded. Electrons drifted toward atomic nuclei and settled into orbit. The first neutral atoms formed, the fog lifted, and in a single cosmic instant, after an eternity of imprisonment, light was finally free. That light never stopped. It is moving right now, at this very moment, passing through the room around you, through your body, through the planet beneath your feet. The oldest light in all of existence, released when the universe was a newborn, filling every direction you could ever look. Astronomers gave it a name, the cosmic microwave background. For decades, it was treated as one of science's great triumphs. It confirmed the Big Bang. It handed us a photograph of the infant universe, frozen at the precise moment it became transparent. And when researchers finally mapped this ancient radiation, they knew exactly what they expected to find: faint temperature ripples. The gentle seeds from which every galaxy, every star, every world would one day grow. And that is exactly what they found. Almost. Because buried inside the most peaceful portrait humanity had ever taken of the early universe was something that did not belong. And the first scientists to see it were certain it had to be a mistake. They were wrong. The story begins in the early 2000s. A spacecraft drifted far beyond the moon's orbit, locked onto a point in space where the gravity of the Earth and the Sun cancel into perfect stillness. Its name was the Wilkinson Microwave Anisotropy Probe, or WMAP. Its mission was breathtakingly ambitious. It would measure the temperature of the entire sky, not roughly, not approximately, but with a precision no instrument in history had ever achieved. The goal was never just to draw a map. The scientists behind WMAP wanted to read the universe's birth certificate, its age, its shape, its hidden composition, all written in the faint warmth of light that had traveled for nearly 14 billion years. And as the data flowed in, it transformed cosmology. The maps revealed the ghostly architecture of the early cosmos. They sharpened our estimate of the universe's age. They strengthened the standard model into something that felt, for the first time, almost complete. And then the researchers saw it. One region of the sky was colder than expected. Not slightly, far colder. The first instinct of any good scientist is doubt. Surely it was an error. A glitch in the instruments, contamination in the data. some nearby source bleeding interference into the measurement. Every possibility was hunted down. Every alternative was tested. And one by one, they failed. The cold spot would not disappear. It was real. Years later, a new machine arrived to settle the question. The European Space Agency launched Planck, a spacecraft carrying instruments so sensitive they made WMAP look primitive by comparison. Planck produced the most detailed image of the cosmic microwave background ever created. If the cold spot were a mistake, Planck would expose it. There would be nowhere left to hide. Instead, Planck confirmed it. The anomaly was still there, sharper, clearer, and more mysterious than ever. Now scientists faced a question that would haunt them for decades. Not whether the cold spot was real, but what in the universe could possibly create it. The first answer seemed almost obvious. There had to be something in the way. They went looking for it. And what they found only deepened the mystery. To understand why the cold spot is so disturbing, you first have to understand what this ancient light truly is. The light we capture today began its journey nearly 13.8 billion years ago. Every direction we point a telescope reveals a different sliver of that same first portrait. And the temperature differences hidden in that light are almost unimaginably small. Most vary by only a few millionths of a degree, whispers of warmth and cold, bordering on silence. Yet those whispers are everything, because written into those tiny fluctuations is the blueprint for all that would ever exist. The galaxies, the clusters, the superclusters, the vast luminous filaments of the cosmic web. Every structure in the universe, including the one you're standing on, grew from those microscopic seeds. The Standard Model predicts, with stunning accuracy, how those fluctuations should be arranged. And almost everywhere we look, the predictions hold. The universe behaves. The numbers agree. Everywhere, that is, except one place. The cold spot is too large and too cold to fit the pattern. Statistically, it is an outlier. Not impossible, but deeply, stubbornly unlikely. And in science, the word unlikely is never a conclusion. It's an invitation. So the hunt began for whatever could carve a frozen wound into the dawn of time. The first suspect was something vast, dark, and almost completely empty. The first major explanation was elegant in its simplicity. What if something stood between us and the cold spot? Something so vast it could drain the warmth from light passing through it. Researchers began searching for cosmic voids. A void is exactly what the name suggests. A colossal region of space almost entirely empty of galaxies. Imagine drifting through a stretch of the universe where galaxies grow rare, then rarer, then vanish altogether. The clusters disappear. The light fades. Space stretches outward into an emptiness so vast it becomes difficult to comprehend. These regions are real. They thread through the cosmic web like enormous hollows between luminous filaments of galaxies. And some scientists wondered if one of them could explain the cold spot. The idea rested on a subtle and beautiful piece of physics. As light crosses a gigantic void, it can lose a small amount of energy along the way. A phenomenon known as the integrated Sachs-Wolf effect. In an expanding universe dominated by dark energy, a photon climbing into a vast empty region never fully recovers the energy it spent. It emerges slightly cooler than it began. Multiply that effect across a void large enough, and you might carve a cold patch into the oldest light in the universe. It was a thrilling possibility. If a single supervoid lay along our line of sight, one of cosmology's greatest mysteries might dissolve into ordinary physics. So astronomers went looking. They mapped galaxies across enormous regions of space. They measured distances. They surveyed the exact direction of the cold spot. searching for a hole in the universe large enough to be responsible. And eventually they found one, a supervoid, a genuinely immense underdense region of space, sitting roughly where the theory predicted it should be. For a brief moment, it seemed the mystery might finally be solved. The evidence appeared promising. The location matched. The idea made sense, and many researchers hoped the case was closed. But then the calculations continued, and the excitement began to fade. The supervoid was too small, too shallow, too weak. It could explain part of the temperature difference, but not all of it. No matter how researchers adjusted the numbers, the result remained the same. The cold spot stayed colder than the void could account for. The most obvious answer had failed. And when the obvious answer fails, scientists are forced to consider possibilities that once seemed unthinkable. Because if a hole in our universe couldn't explain the cold spot, then perhaps the explanation didn't come from our universe at all. This is the moment the mystery stops being a puzzle and starts becoming something close to awe. There was, of course, a quieter possibility that the cold spot was nothing more than an extraordinary stroke of cosmic luck, a statistical fluke, an unlikely ripple frozen into the ancient light. The universe is enormous. Strange things happen. Some cosmologists argued that humanity had simply become fascinated by a curiosity that only felt significant because it caught our attention. And perhaps they were right. But the cold spot refused to cooperate. Its scale, its shape, its stubborn persistence across multiple observations, instrument after instrument, year after year. The harder scientists looked, the less it behaved like a random accident should. It would not be dismissed. And so the theories reached further, into an idea that sounds like pure science fiction, another universe. To follow this possibility, we have to leave our own cosmos behind. According to some models of cosmic inflation, the explosive expansion that occurred during the first fraction of a second after the Big Bang may never have fully stopped. In certain versions of the theory, inflation is eternal. And if it is, then our universe may not be the only one. Imagine an endless cosmic ocean. Within it, universes are born like bubbles, each expanding into a reality of its own, with its own stars, its own galaxies, its own history. Some may even possess laws of physics completely different from ours. For most of these universes, contact would be impossible. They would race away from one another faster than light could ever bridge the distance, forever isolated, forever unreachable. But what if in the chaos of the beginning, two of those bubbles touched? What if our universe in its infancy collided with another? This would be nothing like two planets crashing together, or even two galaxies merging. It would occur on a scale almost beyond imagination. Entire universes pressing against one another, their boundaries interacting during the earliest moments of existence. And a collision like that could leave a mark, a bruise in the fabric of space itself, a scar that might still be visible billions of years later. Some physicists proposed that the cold spot could be exactly that, a fossil imprint left behind by contact with another reality, a wound where our universe once brushed against a neighbor we can never directly observe. If that idea were true, the implications would be staggering. The cold spot would become the first observable hint that our universe is not alone. A single cold region in the sky transforming the multiverse from speculation into something approaching evidence. Think about what that would mean. That beyond everything we can see, beyond every galaxy, beyond the edge of the observable universe itself, other universes may exist, and one of them may have touched ours, leaving behind a fingerprint that we are still studying today, more than 13 billion years later. It is a breathtaking possibility. But breathtaking is not the same as proven. Extraordinary claims demand extraordinary evidence, and that evidence remains frustratingly elusive. Researchers search for the precise patterns a bubble collision should leave behind. Some studies reported intriguing hints. Others found nothing at all. The results remained inconclusive, tantalizing, but never decisive. The theory survived, yet it remained unconfirmed. And so the most dramatic explanation for the cold spot remained just out of reach, a possibility suspended between science and mystery, which left researchers with one final, humbling question. What if the cold spot is not revealing another universe? What if it is revealing a flaw in our understanding of this one? As the years passed, a new and humbling possibility began to emerge. What if the cold spot wasn't revealing a flaw in the universe, but a flaw in our understanding of it? Modern cosmology is one of humanity's greatest intellectual achievements. It explains the expansion of space, the formation of galaxies, the abundance of elements created in the first minutes after the Big Bang, the growth of cosmic structure across billions of years. By almost every measure, it works remarkably well. And yet, beneath that success lies a profound mystery, because our model of the universe depends heavily on ingredients we still do not understand. Dark matter, an invisible substance that appears to hold galaxies together. Dark energy, a mysterious force driving the accelerated expansion of space itself. Together, these unknown components make up the vast majority of the universe, and despite decades of research, no one knows exactly what they are. So, some scientists began asking a difficult question. Could the cold spot be a crack in the foundation? A clue that our current picture of reality is incomplete? Perhaps the anomaly is not a statistical accident, not a supervoid, not evidence of another universe, but a sign that something important is missing from our theories. Some researchers suggested that unknown processes operating during the earliest moments of cosmic history may have created structures unlike anything predicted by standard cosmology. Others propose something even more profound. That traces of quantum physics from the birth of the universe might still be imprinted on the cosmic microwave background, tiny fingerprints left behind when reality itself was still taking shape. These ideas remain speculative. Few scientists would claim they have compelling evidence for them, but the cold spot keeps such possibilities alive, because every unexplained anomaly creates an opportunity for discovery, an opportunity for revision, an opportunity to learn that reality is stranger than we imagined. History has seen this before. Again and again, small discrepancies have led to enormous breakthroughs. In the 19th century, revealed entirely new layers of reality. Time after time, the things that shouldn't exist have transformed our understanding of the universe. The cold spot may one day join that list, or it may not. Perhaps future observations will reveal an ordinary explanation hiding beneath the mystery. Or perhaps this anomaly is pointing towards something entirely new. That uncertainty is precisely what makes it so compelling. Because after more than 20 years of investigation, after satellites, surveys, simulations, and countless scientific papers, no one can say with confidence which possibility is correct. And that leaves us with a final question. Where does the mystery stand today? Today, the hunt continues. Astronomers around the world are still studying the cold spot with increasingly powerful instruments. New galaxy surveys map the large-scale structure of the universe with unprecedented precision. Advanced telescopes probe deeper into space than ever before. Supercomputers simulate billions of years of cosmic evolution, searching for clues that might finally explain the anomaly. And yet, despite all of this effort, the cold spot remains unsolved. The supervoid explanation appears incomplete. The statistical fluctuation explanation remains controversial. The multiverse hypothesis remains unproven, and no alternative theory has achieved widespread acceptance. Every path seems to lead back to the same place: uncertainty. The mystery endures. Perhaps the answer lies in observations that have not yet been made. Perhaps future telescopes will uncover hidden structures invisible to us today. Perhaps new physics is waiting just beyond the horizon of current knowledge. Or perhaps the cold spot will eventually be explained by mechanisms we already understand, reducing one of cosmology's greatest mysteries to an extraordinary coincidence. For now, no one knows, and that uncertainty leads to a deeper question. What does it mean that one of the oldest signals in the universe still contains a message we cannot decipher? The cosmic microwave background is often described as a photograph of the infant universe. If that comparison is true, then the cold spot is the detail in the image that refuses to make sense. A shadow where none should exist. A puzzle hidden within the oldest light in existence. A reminder that even after centuries of scientific discovery, the universe still holds secrets beyond our understanding. Every night, as our planet turns beneath the stars, ancient radiation from the Big Bang continues its endless journey across the cosmos. Invisible, silent, older than every galaxy, older than every star, older than the Earth itself. And woven into that ancient glow is a region that challenges our understanding of reality. A region that should not exist. A region that may someday reveal something profound about the universe. Or perhaps about ourselves. Because the cold spot is more than an anomaly. It is a reminder. A reminder that humanity's map of the cosmos remains unfinished. That there are chapters of the cosmic story we have not yet learned to read, and that somewhere within the oldest light in existence, a mystery still waits for an answer. If the answer is hidden inside the cold spot, then we may be looking at one of the most important clues humanity has ever discovered. A clue that could tell us whether our universe is unique or merely one among countless others. Until that answer arrives, one question remains. Are we looking at a cosmic coincidence or evidence that reality is far larger than we ever imagined? The cold spot remains, silent, ancient, unexplained, and perhaps that is exactly what makes it one of the most extraordinary places in the entire universe.